Arumugalakshmi from Sri Jaindra Saraswati Vidyalaya Matriculation High Secondary School, Singanallur. Today we are going to discuss the problems in Lesson 5 Electromagnetic Waves. Namaste. Today we are going to discuss about the problems in Lesson 5 Electromagnetic Waves of Class 12 Physics. First problem. Consider a parallel plate capacitor whose plates are closely spaced. Let R be the radius of the plates and the current in the wire connected to the plates is 5 ampere. Calculate the displacement current through the surface passing between the plates by directly calculating the rate of change of flux of electric field through the surface. So let us start the problem with the given data. That is, the conduction current IC is given as 5 ampere. First we will start with the Gauss law, which is phi equal to Q by epsilon naught, which is your Gauss law. We have to calculate the displacement current. So the formula for displacement current is I suffix d is equal to epsilon naught into d phi by dt. Now here instead of phi we are going to apply our Gauss law. So phi is equal to q by epsilon naught. This I am going to substitute in the displacement current equation. Therefore id is equal to epsilon naught into d by dt of, instead of phi, our Gauss law, which is q by epsilon naught. So displacement current is equal to epsilon naught into d by dt of q by epsilon naught. So when you differentiate the constant, we have to take it outside. So the constant here is epsilon naught. So epsilon naught I am taking it outside. Already outside in the numerator we have got an epsilon naught. Now once again in the denominator we are moving the epsilon naught into dq by dt. So the epsilon naught which is in the numerator and denominator gets cancelled. So id is equal to dq by dt. Now here we are going to substitute the expression for q. So the expression for q we will be taking from the conduction current. IC is equal to q by t. From this equation q is equal to IC into t. Now we substitute this q in the displacement current, which is id is equal to d by dt of IC into t. Instead of q we have substituted ICT. Now you have to differentiate this. So when you differentiating, once again the constant you will take it outside. So IC into dt by dt. dt by dt the value is 1. Hence, ID is equal to IC. IC value is given in the data as 5 ampere. So, the displacement current is also equal to 5 ampere. So, the final answer is displacement current is equal to 5 ampere. Now, the second problem. A transmitter consists of an LC circuit with an inductance of 1 microhenry and capacitance of 1 microfarad. What is the wavelength of the electromagnetic wave it emits? So first we will start with the given data. Inductance of LC circuit L is given as 1 microhenry. Micro means we know that it is 10 power minus 6 Henry. And capacitance of LC circuit C is equal to 1 microfarad. So which is equal to 1 into 10 power minus 6 farad. We are supposed to find the wavelength of the electromagnetic wave. So wavelength, the formula is lambda is equal to C by F. C value we know that it is the velocity of light, which is equal to 3 into 10 power 8 meter per second. So we need to find the frequency. So first we will find the frequency. After that we will substitute in the formula lambda is equal to C by F to find the wavelength of the electromagnetic wave. We know the frequency of the electromagnetic wave. The expression is F is equal to 1 by 2 pi root of LC. L value is given in the data. C value is given in the data. Substitute in this equation, which gives 1 by 2 into the pi value is 3.14 into square root of LC value. LC value is 10 power minus 6 into 10 power minus 6. So when you take the root, it will become 10 power minus 6. So the answer is 1 divided by 6.28 into 10 power minus 6, which is equal to 15.92 into 10 power 4 Hertz. This is the frequency. Now this frequency value and the velocity of light c value, which is 3 into 10 power 8 meter per second, we have to substitute in the lambda value, which is lambda is equal to c by f. So substituting, we will get lambda is equal to c by f, which is equal to 3 into 10 power 8 divided by 15.92 into 10 power 4, which gives 0.1884 into 10 power 4. This can be written as lambda is equal to 18.84 into 10 power 2 meter. So the answer is the wavelength of the given electromagnetic wave is 18.84 into 10 power 2 meter. Now the third problem. A pulse of light of duration 10 power minus 6 second is observed completely by a small object initially at rest. If the power of the pulse is 60 into 10 power minus 3 watt, calculate the final momentum of the object. So as usual, we will start with the given data. The duration of the absorption of the light pulse t is equal to 10 power minus 6 second. Power of the pulse P is equal to 60 into 10 power minus 3 watt. We are supposed to find the final momentum. So momentum is given by P is equal to U by C. We know the value of C as 3 into 10 power 8 meter per second. So first we have to calculate the U value, that is the energy. The formula for energy is power into time. Power and time is given in the data. Just substitute that. So momentum P is equal to 60 into 10 power minus 3 into 10 power minus 6 divided by 3 into 10 power 8, which is equal to P is equal to 20 into 10 power minus 17 kilogram meter per second. Therefore, the final momentum of the object is 20 into 10 power minus 17 kilogram meter per second. Fourth problem. Let an electromagnetic wave propagation along the x direction. The magnetic field oscillates at a frequency of 10 power 10 Hz and has an amplitude of 10 power minus 5 Tesla acting along the y direction. Then compute the wavelength of the wave. Also write down the expression for the electric field in this case. So first let us write the given data. The frequency of the electromagnetic wave V is equal to 10 power 10 Hz. The amplitude of the oscillating magnetic field B0 is equal to 10 power minus 5 Tesla. So first let us find the wavelength. Lambda is equal to, we know the formula for lambda. Lambda is equal to c by f, where c is the velocity of light, f is given. So substitute the known values. So lambda is equal to 3 into 10 power 8 divided by 10 power 10, which is equal to 3 into 10 power minus 2 meter. This is the wavelength. Now we will find the amplitude of the oscillating electric field E0. Using the equation E0 is equal to B0 into C. So from where did you get this equation? We got it from the expression C is equal to E0 by B0. So E0 is equal to, substitute this B0 and C value, you will get the value of E0 as 10 power minus 5 into 3 into 10 power 8, which is equal to 3 into 10 power 3 Newton per Coulomb. Since it is an electric field, its unit is Newton per Coulomb. Now we will find the expression for electric field in an oscillating wave. We know the expression for electric field as E is equal to E0 sin kx minus omega t. So we need to find the value of k and omega. So the value of k is equal to 2 pi by lambda. Lambda value already we have found, that you have to substitute in this equation to get the value of k. So K is equal to 2 pi by lambda, which is equal to 2 into 3.14 divided by 3 into 10 power minus 2, which is equal to 209 into 10 power 2. Next, we will find the value of omega, which is equal to 2 pi f. 2 pi value is 3.141 into frequency. It is given in the data as 10 power 10. So 2 into 3.14 into 10 power 10, which is equal to 6.28 into 10 power 10 is the omega value. Now substitute all in this equation. E is equal to E naught sine kx minus omega t. Then you will get the expression for electric field as E is equal to 3 into 10 power 3 sine of 2.09 into 10 power 2 into minus 6.28 into 10 power 10 t into I cap Newton per Coulomb. Now problem 5. If the relative permeability and relative permittivity of the medium is 1 and 2.25 respectively, find the speed of the electromagnetic wave in this medium. So the given data is relative permeability of the medium mu r is equal to 1 and relative permittivity of the medium epsilon r is equal to 2.25. We need to find the speed of the electromagnetic wave in the medium. So we know the formula as epsilon r is equal to epsilon divided by epsilon naught and mu r is equal to mu by mu naught. So the speed of the electromagnetic wave V is equal to 1 by square root of mu into epsilon. So we need to find the value of mu and epsilon from the above formula. So it becomes 1 by square root of mu r into mu naught into epsilon r into epsilon naught. We know the relation between speed of the light and the relative permeability and relative permittivity as C is equal to 1 by square root of mu naught into epsilon naught. So instead of 1 by square root of mu naught into epsilon naught, we are going to substitute as C. So the equation for speed of the electromagnetic wave V becomes C divided by square root of mu r into epsilon r. Mu r and epsilon r values are given in the data. So substitute these values. So you will get the answer as 3 into 10 power 8 divided by square root of 1 into 2.25, which is equal to 3 into 10 power 8 divided by 1.5. So the answer is V is equal to 2 into 10 power 8 meter per second. So the speed of the electromagnetic wave in the medium is 2 into 10 power 8 meter per second. Sixth problem. A magnetron in a microwave oven emits electromagnetic waves with the frequency f is equal to 2450 MHz. What magnetic field strength is required for the electrons to move in circular paths with this frequency? So as usual, we will start with the given data. The frequency of the electromagnetic waves is given as f is equal to 2450 MHz. So the corresponding angular frequency we will first find. So omega is equal to 2 pi f, which is equal to 2 into 3.14 into 2450 into 10 power 6, which is equal to 15,386 into 10 power 6 Hertz, which is equal to 1.54 into 10 power 10 Hertz. So the required magnetic field B is equal to m omega divided by q, where m is the mass of the electron, whose value we know that 9.11 into 10 power minus 31. Similarly, q is the charge of the electron, whose value we know as q is equal to 1.6 into 10 power minus 19 Coulomb. So these value we have to substitute in the magnetic field equation. So we get the answer as B is equal to 9.11 into 10 power minus 31 into 1.54 into 10 power 10 the whole divided by 1.6 into 10 power minus 19, which is equal to 8.7683 into 10 power minus 2 Tesla. So the magnetic field value is given as B is equal to 0.08768 Tesla. Seventh problem. The relative magnetic permeability of the medium is 2.5 and the relative electrical permittivity of the medium is 2.25. Compute the refractive index of the medium. So first let us write the given data. The dielectric constant, that is the relative permittivity of the medium epsilon r is equal to 2.25. The magnetic permeability mu r is equal to 2.5. We are supposed to find the refractive index of the medium. We know the formula as refractive index is equal to square root of epsilon r into mu r. So substitute the given values. N is equal to square root of 2.25 into 2.5, which is equal to 2.37. So the refractive index of the medium is 2.3. The last problem. Consider a parallel plate capacitor which is connected to an 230 volt RMS value and 50 Hz frequency. If the separation distance between the plates of the capacitor and area of the plates are 1 mm and 20 cm square respectively, calculate the displacement current at t is equal to 1 second. So we have to find the displacement current. So first let us find the potential difference between the plates of the capacitor. We know that V is equal to V max into sine 2 pi ft. That is 2 pi omega. Instead of omega we have written as f into t. So which is equal to V max value we have to substitute it as 230. So V is equal to 230 into root 2 into sine 2 pi into 50t, which is equal to V is equal to 325 sine 100 pi t. And next the small d value is given as 1 millimeter, which we have to convert it into SI unit, which is equal to 1 into 10 power minus 3 meter. Then we will find the area. Area is equal to 20 centimeter square. Once again this we have to convert it into SI unit, which is equal to 20 into 10 power minus 4 meter square. Now we will find the displacement current. ID is equal to epsilon naught into d phi by dt. Instead of phi, we are going to substitute it as E into A. Phi is equal to EA. Now here once again, instead of capital E, that is the electric field, we are going to substitute the formula E is equal to V by D. So the expression for displacement current becomes ID is equal to epsilon naught A divided by D into dV by dt. Now substitute all the values from the given in this equation. So the equation becomes epsilon naught A divided by small d into 325 100 pi cos 100 pi t. Now substitute the value of A and D. So the equation becomes 8.85 into 10 power minus 12 into 20 into 10 power minus 4 into 325 into 100 into 3.14 into 100 pi into 1. So the whole divided by 1 into 10 power minus 3. So the answer is 1.81 into 10 power minus 6 ampere, which can also be written as 1.81 microampere. So the displacement current flowing is 1.81 microampere.